Hello there, Dan the Weatherman here. Hey, welcome to my weather show. The big story this week, of course, is the massive tornado outbreak across the eastern parts of the US. On this globe satellite, you can still see the main trail of cloud from the storm system as it exits parts of North America. And, you know, some of the scenes of just utter devastation. Phenomenal. These sorts of scenes, even on an intense tornado outbreak in spring storm season, this would be just absolutely frightening. But we're in winter. We're just days before Christmas. How on earth, do we get stuff like this? What is going on? This is the radar loop. So green, of course, was the rain. The yellow dots, those were the intense thunderstorms and even some red blobs too. There were some 44 tornadoes in the span of 24 hours that spawned from parts of Arkansas through Tennessee, Kentucky. On the back edge of it, on that intense line of thunderstorms, that's the cold air. That's blue is the area of snow wrapping around. But normally with thunderstorms, daytime heating, cloud bubbles up, thunderstorm. But a lot of these nasty thunderstorms and tornadoes, they came through in the middle of the night. How does this happen? There has to be something else. And there was, and it was pretty intense. An upper level trigger, or what we call upper level energy, vorticity. That main red line there, this is the upper level streamlines in the middle level of the atmosphere, and this just looks nasty. That, of course, was the zone of oomph in the atmosphere. So you've got the daytime heating, but it didn't matter. At night, these storms were going. That gives you that extra twist that creates the twist in the thunderstorm, and that, of course, just develops those tornadoes and drops them down. And some of these tornadoes, they were just raging for as far as some 200 miles or even further, just phenomenal distances. That, if you can believe it, and of course the intensity of this can actually be traced back to Siberia in the early part of the week. And then you're thinking, how? Cold Siberia? It was cold, near record cold, that blob of purple there early in the week. That was a cold surge coming down, the darker purple there, minus 40 to minus 50 degrees Celsius. And then you're still thinking, well, how cold, thunderstorms, intense, how does that work? Well, with weather is like a roller coaster ride. What goes down has to come up. So this was the going down bit, a cold surge. That also had a weak little upper level disturbance in the atmosphere. These are the streamlines, that's eastern parts of Asia. I've circled it there. Can you see that little bend there? That was the upper disturbance, but the big key thing was that cold air, the upper disturbance, moving across the very, very warm seas of the Pacific Ocean. This is the Pacific Ocean, that's Asia, that's Alaska, North America. That red, and particularly that darker blob there, this is some 3 to 5 degrees warmer than normal. This is the North Pacific warm blob. So you think of it, cold air, warm, that just creates contrast, and this just invigorates the upper levels of the atmosphere. This has even played a part, if you can believe it, in the devastating floods that we saw in the atmospheric river across western parts of Canada several weeks ago. So this is affecting the weather, and this, of course, has warmed, has developed just because of our warming planet recently. So that was the little kink there. Let's put this into motion. I want to show you it happens. So cold air, little disturbance, that moves across the warm sea. And you see that orange and the red there surging across parts of Alaska, coming down, and then like a roller coaster ride, vroom, straight down. It dives down, and then watch that V, that nasty shape of a V. That's the intense area there that spawned those tornadoes and that massive, massive outbreak of storms across eastern parts of the US right there. All down to the erratic nature of the jet stream, the warming planet, and unfortunately these sorts of extremes that we see will become more commonplace with our warming planet. That's the weather for now.